Alright, so this lesson today is on another functional group called ethers. This is not ethers, this is ethers. So this is like a long E here. Ethers, and the stress would be on the first syllable here, ethers. Ethers, okay? An ether is an organic compound containing an oxygen atom bonded to two carbon atoms. Okay, so that should be underlined as well. Oxygen and two carbons. So you look down here at these examples, okay? Here is, it's called propyl ether, we'll get into naming in a second. But you see in this structure, this oxygen is bonded to the carbon, even though the H is listed right there, the oxygen is not bonded to the H, okay? It's actually bonded to the C. And if I were to draw, this molecule over here, this would be an O, and it would be coming to the C, bonded to the C, and these H's would be right here, right? But when you're, writing the compound this way, then it's the C comes first and then the H's. So it's bonded to a C here, and the O is also bonded to a C over here, where the H's are here as well. Okay? So this characteristic right here, COC, is an ether. When naming ethers that have two identical alkyl chains, so you remember what alkyl means, it means the carbon chains, right? There's the alkyl and there's the aryl that we talked about earlier. The alkyl is the carbon chains. When we have two identical chains, you first name the alkyl group and then add the word ether. So it's just the group plus ether. So this example here, we just kind of get rid of some of this stuff again. This is meth F prop, right? So 3 carbons is propane, or the alkyl group is propyl. This is 1, 2, 3. This is also propyl. So when we have two identical alkyl chains, we just say propyl ether. Propyl ether. Another example over here. This is 1, 2, 3, 4, 5, 6 in a circular chain or hexagonal shape. So that is cyclohexyl ether. Cyclohexyl ether. So that's when they're identical. When they're not identical, there's a bit of a different scheme. But anyways, that's an ether, COC. Excuse me, single bonds here as well. Important to know. If the two alkyl groups are different, then we list them in alphabetical order. And then you follow that with ether as well. So it's pretty straightforward, okay? On this side, you notice that we have 1, 2 carbons, so that's meth F, right? So ethyl over here. And on this side of the ether of the oxygen, we have meth F propyl butyl. Okay, so we have a butyl here. And it says when they're different, you always look to alphabetical in naming them. So B comes before E. That's why it's butyl, ethyl, ether. No commas, no dashes, separate words, butyl, ethyl, ether. Similarly, down here we have ethyl and methyl. So E comes before M in the alphabet. So this is ethyl, methyl, ether. You can get a pretty good tongue twister going, I'm sure, with this group. Butyl, ethyl, ether, meets ethyl, methyl, ether. There you go. Say that fast 5 times. Ready? That's your assignment right now. Methyl, ethyl, ethyl. Actually, it's ethyl, methyl, ether. That's once. 5 times. Ready? On the count of 3, everybody try it. Ethyl, methyl, ether as fast as you can 5 times. Ready? 1, 2, 3. Ethyl, methyl, ether. Ethyl, methyl, ether. Ethyl, methyl, ether. Ethyl, methyl, ethyl, methyl. Yeah, you guys are just as pathetic as me. Okay, so that's right. Hey, I just admitted I was pathetic. Okay. I'm not in radio. I mean, I have a face for radio, but I do not have the lips for radio. I wish. Okay, that was a little bit of a joke. You can laugh at that joke, face for radio. Okay, anyways, are we good? You guys good? Can I move on? Okay. Now you're all agreeing. Thank you. Okay, properties or uses of ethers. Okay, again, remember, you do not have to copy out this word for word. Please just hit the highlights. Okay, the term ether was first used in chemistry as a name for ethyl ether. Can hardly say even that now. The volatile, highly flammable substance that was commonly used as an anesthetic in surgery. Isn't that awesome? volatile, highly flammable. So what are you going to do? We're going to ingest it just before we cut you open. That's nice. In 1842 until the 20th century. Okay, so that's good. Yeah, don't smoke and drink this before your surgery. You will explode. Because ethers have no hydrogen atoms bonded to the oxygen, their molecules cannot form hydrogen bonds with each other. Okay, so can't form hydrogen bonds. Therefore, ethers are generally more volatile and have lower boiling points. So you might have written that they're volatile already. So volatile because each of the molecules, they don't have much attraction for each other. That hydrogen bonding is not really there. So there's not as much attraction for each other. So the boiling points are lower. It's easier to break them up to change phase and stuff. And they'll react a little bit easier. Ethers are also much less soluble in water than alcohols because they have no hydrogen to donate to a hydrogen bond, but the oxygen can act as a hydrogen bond receptor. So again, the reasons, you don't have to get all these reasons. These notes are on Student Share for you to look at or whatever. But if you just kind of hit the highlights, okay, initially used as an anesthetic a couple hundred years ago. It's very volatile with low boiling point, and it's less soluble than alcohol. Alright, so let's pause for a little naming activity here. You've got some ethers, some chains, some diagrams, structural formulas. Why don't you take your opportunity here to look back to your naming rules and try and name these four. I'll give you a couple minutes to do that. Alright, so the first one should be pretty straightforward. I think maybe even this was an example here, but it's meth-eth, right? So it's ethyl ether, correct? Ethyl ether, you got that? Good. So here, this group is a methyl group. 1, 2, 3, 4, what's that? Butyl group. Which one comes first alphabetically? Nice. Butyl, methyl, ether. Correct? Okay, you liking that? Awesome. Alright, this is cyclo something, right? Even though it's a square, call it cyclo. But 1, 2, 3, 4, meth, eth, prop, but. So what is this one? Cyclobutyl, right. Cyclobutyl space ether. You may have had trouble with D here. Just wondering about the alphabetical naming thing. Okay. I've seen it written both ways. Like this is ethyl, right? And this is cyclo what? Meth, eth, prop. Cyclopropyl. Okay. So which comes first alphabetically? Do you name the cyclos first? In most occurrences that I've seen, you do name the cyclos first, no matter what the alphabetical is. So if there's a cyclo, if there's one cyclo, then name that first. So I would call the cyclopropyl ethyl ether. Like I say, I've looked up on the internet and I've seen it written both ways. I've seen it ethyl cyclopropyl ether, but many more times with the cyclo first. So we're going to go with that. Yeah. I think what we're gonna do is I think we'll name the cyclos first. Yeah, I think that's the convention. Although maybe further research might reveal something different, but we'll do the cyclo first and then the other group, no matter what. Even if it's butyl, yeah. All right. So here are some names now. Why don't you take a few minutes to draw the structures, and you can draw them like this, or you can do this with the H's off there as well. It doesn't matter to me. Okay. All right. So let's just go through each of these. Methyl ether. There's only one alkyl group mentioned, so that means it's identical on both sides of the oxygen, right? So we have CH3 bonded to an O, bonded to another CH3. There's your methyl group here and here. B. Now, butyl pentyl ether. Okay, butyl is 1, 2, 3, 4 carbons. Pentyl is 5, right? Penta, 1, 2, 3, 4, 5. So you have the carbon chain here, butyl, carbon chain, pentyl. It doesn't matter which order you write it in, right? And then the O in the middle. The reason why I drew D the way I did was because I just wanted to make sure that you are understanding here that on the ends it's CH3, and any carbons that are bonded kind of sort of in the middle would be CH2, right? And the reason why, of course, that is because in the ends, carbon needs 4 bonds, 1 to the O, and then, there's 3 hydrogens, so that's the CH3 part. And in the middle, carbon is bonded to, let's say the oxygen here, and another carbon over here, so there's only 2 hydrogens needed to fill out the 4 bonds, right? So just as long as you know that CH3 on the ends, and then CH2's in the middle. And we missed C here, so cyclobutyl-methyl ether. Cyclo is in a ring, butyl is 4 carbons, 1, 2, 3, 4. Methyl is your group on the end here, and so that would be your structural diagram for cyclobutyl-methyl ether. Lots of tongue twisters. The next functional group that we're going to study is called amines. Opposed to amines? Yes, amines. Alright, so amines contain nitrogen atoms bonded to carbon atoms in aliphatic chains or aromatic rings. Okay, so basically straight chains with nitrogen or, in rings. So the aromatic, remember the aroma type molecules are in circles lots of times. So they have the general formula of R. Remember, R is some kind of carbon chain or carbon group. RNH2. Okay, so you've got an N and you've got H2. Chemists consider amines to be derivatives of ammonia. So ammonia is NH3, and you can kind of see that it's pretty close. You take off a hydrogen, add a carbon group, and you've got your amines. Amines are considered primary, secondary, or tertiary amines depending on whether 1, 2, or 3 of the hydrogens in ammonia have been replaced by organic groups. So I'll give you a chance to copy that whole thing down. All right. If 1 hydrogen has been replaced, so it's just RNH2, we've got a primary amine and so on. Secondary with 2 hydrogens replaced. Tertiary is the word that you often will hear in organic chemistry, meaning 3, and that's if the 3 hydrogens have been replaced by organic groups. So I'll let you copy this whole thing down. Let's talk about naming amines. Excuse me. The NH2 group, okay, so the amino group. You ever heard that word amino before? Amino acids, yes, so from biology, right? Amino. So the amines have an amino group. It's indicated by the suffix amine. So let's take a look at something simple here. We have 2 carbons, okay, a 2-carbon chain, which would be ethane, right? And if one of the hydrogens is replaced by an amine group, we have ethanamine. Okay, all one word. Ethanamine, ethanamine. Okay, so ethane, the root there, and then the amine suffix. This, of course, is it's not benzene because it doesn't have this circle inside. If this circle was inside, we have different bonding between all those atoms, and that's a benzene ring, but we don't have that. So this is just cyclohexane, right? So we have here in this one, because we have an amine group attached, it's cyclohexyl, because the carbon group would be a hexyl group, and amine, cyclohexylamine. When necessary, the position of the amino group is designated by a number. So that's consistent with other naming practices, right? If we have an amine group, an amino group on the first carbon, we would name it, 1. Or if it was on the second here, we would name it 2 dash, right? So this one here, because it's there's 4, 1, 2, 3, 4 carbons, and nitrogen, of course, we wouldn't say 4, right? We would always use the lowest number possible. So this is a 1 dash, dash between numbers and letters, 1 dash butanamine. But, 1, 2, 3, 4 carbons, butanamine. 1 butanamine. Okay? And of course, if it was, if it looked like this, oops, right, this, okay, then this would be 2-butanamine, right? Because we're on the second carbon over here. So 1, 2. This would be 2-butanamine. Would not be 3. You wouldn't count, hey, let's count left to right. 1, 2, 3. No, not that way. Keep the numbers as low as possible. Okay, so that's naming some simple amino groups, amines. All right, so yeah, the question was raised, why ethanamine, and why is that also here under ethylamine? And actually, ethylamine should be the name that we would use, but we've just found at pubchem.ncbi.nlm.nih.gov that the chemical names, there's a whole list of chemical names here, and we see that ethanamine is listed as one of them. Ethylamine, this is in capital letters, so this is going to be the one that's probably more readily used. This will be following the rules, so we will say ethylamine. Also, monoethylamine wouldn't be wrong, but aminoethane is also used, 1-aminoethane, ethylamine solution, and so on. So, yeah, so you see this occurrence in different chemical publications. But yeah, we'll go with ethylamine and not ethanamine. Okay, thanks for noting that. Try and keep the YLs. So then under here, you would also be allowed to call this 1-butylamine and 2-butylamine. The 1 means it's bonded to the first carbon, yeah. I guess the thing that you'd have to make allowances for, and the reason why this is going to be, would be an okay way to say this, is because what happens if you have a double bond, I guess, right? So then it's going to be, butene, right? You have to have the ene in there to indicate that there's a double bond. So what if there's a double bond right here? Do you know what I mean? So you have to leave that option open. If it's just butyl, then it's all single bonds, just what this ane would indicate. But if there was a double bond here for some reason, then you'd have to have the ability to identify that double bond, right? So yeah, so butanamine, that's fine, means single bonds there. But if it's just single bonds, you could also call it butylamine. So, as you can see in these notes, it does kind of go with the, instead of the ill, it's the ane, so whatever. Both ways are fine. If more than one amino group is present, however, prefixes are needed. So in this case here, meth, eth, prop, we have 2 amines. So you would name this 1,3-propyldiamine or propanadiamine. So make sure you remember that the root here is propane or propyl, and we have 2 amino functional groups here. So that's the di and then amine. So it's 1,3-propyldiamine or propanadiamine. And here, okay, we've got 4, so this is pretty busy right here. But they're all amino functional groups, amine groups, and they're on the 1 and 4. And of course, as convention states, if there's 2 on the 1, you'd have to list the number 1 twice. And then there's 2 on the 4, so you list the 4 twice. Remember, commas between the numbers, dashes between letters and words, numbers and words. And so we have 1, 1, 4, 4, butyl or butana, and how many are there? 1, 2, 3, 4, right? So we've got mono, which we don't use, di, tri, tetra, penta, hexa, and so on. So this is going to be tetraamine. All right, so the question was, why would this not be 1, 1? Because this carbon could be a 1 if you count from this way, and this carbon could also be a 1 if you count from this way. The 1, 1 would not have this amino group here, it would have it over here as well. That means there would be 2 of these amine groups on the first 1 carbon. If you start counting this as 1, you have to keep the counting convention and go, this has got to be 2 then, this has to be 3. So once you start counting one way with the carbons, you have to kind of keep that. Good question, but you can probably see that the 1, 1, right, would be a different structure. Okay, different isomer. Okay, good. Any other questions? Okay, so some notes on the properties and uses of amines. Cyclohexylamine and phthalamine are important in the manufacturing of pesticides. So manufacturing of pesticides, also plastics, pharmaceuticals. Okay, so an amine group, lots of pharmaceutical drugs, and rubber as well, used to make tires. So you need this functional group is very important in the making of all these things. So you can see there's a lot of that's widely used. Aniline, whose structure is over here, and you see we have an amine group bonded to a benzene ring. Common name derived from the plant where it is historically obtained is used in the production of dyes. So aniline is used in the production of dyes with deep shades of color. So very dark dyes often use this chemical aniline. As well, volatile amines have odors that humans find offensive. And amines are responsible for many of the odors characteristic of dead or decaying organisms. So all volatile amines have odors that humans find offensive. So offensive odors, dead or decaying organisms. So, if you're walking in the park and there's a dead squirrel or something and you don't see it but you can smell it, or if you're on a farm and there's some animal has tragically met its death or whatever, you know what that smell is, right? It's like, oh, something's rotting, some animal has died. So here are a couple names for compounds. Interesting, cadaverine. Okay, see the root word for this one is cadaver. You know what a cadaver is? Like it's a dead human body. Okay, so we've got some smells coming from dead human bodies. And also putrescine. Have you ever heard the term, oh, that smells putrid? Putrid. Yeah, putrid is like an awfully offensive, gross kind of smell. That's putrid. So putrescine. So yeah, see, you wouldn't exactly buy a perfume, that's made with these things here. Unless, of course, you were completely antisocial and accomplished your goal. Hi, yes, let's get a little practice. Name the following amines. Amines, all right, name them. Go, 1, 2, 3, go. So, to name these, yes, I would agree that there's 1, 2, 3 carbons, and the amine group is on the second one, so you do 2-propanamine. You could say, because they're all single bonds as well, 2-propylamine, that's fine as well. This one here, 3 carbons, so it's prop again. So on the first one, 1-propanamine or 1-propylamine or just propylamine. All of these would be okay. Okay, they're all okay. You'll see on the internet, as we just kind of did a little bit of a search on different things, there's the 1-propanamine, but certainly there are a lot more hits or a lot more indicators that this is propylamine, and there's your structure. So again, propyl is probably a more common name, but to keep in with the convention of the naming here, propanamine is fine too. Next functional group we're going to talk about is the carbonyl group. Last one for this lesson, the carbonyl group. The arrangement in which oxygen atom is double bonded to carbon is called carbonyl. So similar to the last one, okay, which was this, similar to the ether group anyways, COC. This is C double bonded to O as a group, kind of on its own like this. Okay, so oxygen double bonded to carbon is called the carbonyl group. This group is the functional group in organic compounds known as aldehydes and ketones. So there's 2 subgroups in the carbonyl groups. two subgroups. So wherever you see a C double bonded to an O on its own like that, you know that it's a carbonyl group. There are two subcategories in the carbonyl group, and we'll take a look at aldehydes and ketones. An aldehyde is an organic compound in which a carbonyl group is located at the end of the carbon chain and is bonded to a carbon atom. So at the end of a carbon chain, bonded to a carbon atom on the one side and a hydrogen on the other. So a carbon and a hydrogen. Formaldehyde is an example of an aldehyde, exactly, yes. So aldehydes have the general formula of, and remember this asterisk is some kind of alkyl group or some kind of whatever, something bonded over here. We don't really care about that right now. But we've got C double bonded to the oxygen with it also bonded to an H. So you'll see it CHO instead of M. Not COH because that would look more like a what group? What's the COH if you write it that way? What does that make you think of? OH is hydroxyl, which is alcohol. Yeah, so CHO. So it would come from here, from some group R, C double bonded to an O, and then just a plain old H there. So that's sort of that's what this group would look like, okay? The aldehyde. That's an aldehyde functional group. All right, naming aldehydes pretty easy. If you have one carbon with four H's, that would be methane. If you have one carbon double bonded to an O with hydrogens here, and you can see here's the aldehyde group, right? Then you just change the end of the name. So if it be methane, you change it to methanal. Not all, close. It's close to alcohol, methanol, but it's methanal. Methanol. Methanal. If you have two carbons, it would be ethanal. And we just mentioned formaldehyde was one of the common aldehydes, of course, and that is the common name for methanol, formaldehyde. And acetaldehyde, 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 whatever. I think it's the same. Ethanol. Okay, so you got your aldehyde group there. Because the carbonyl group in an aldehyde always occurs at the end of a carbon chain, no numbers are used unless branches or additional functional groups are present. So no numbers unless you have a different functional group, because it's always at the end. Okay, so it's always at the end of a carbon chain, so there are no numbers if it's just an aldehyde. No numbers unless there are other functional groups present. Properties of aldehydes. An aldehyde molecule contains a polar reactive structure. However, like ethers, aldehyde molecules cannot form hydrogen bonds among themselves because they have no hydrogen atoms bonded to the oxygen. Therefore, aldehydes have lower boiling points than alcohols with the same number of carbon atoms. So they're polar, they're reactive, they cannot form hydrogen bonds, they have low boiling points. Water molecules can form hydrogen bonds with the oxygen atom of aldehyde, so aldehydes are more soluble in water than alkanes, but not as soluble as alcohols or amines. You do not have to memorize this, okay? This is just a side fact, because it'd be difficult for you to memorize that, and we won't have to go there. But just so you know that the solubility is sort of between alkanes and alcohols, and that's a little bit why, but you don't have to remember that. Uses of aldehydes. Formaldehyde, that's the methanol that we just looked at, has been used for preservation for many years. So often formaldehyde is used to preserve specimens for biology. You get that really pungent smell when you're dissecting, right? If you pull the specimens out. I think there's other things that they use sometimes now, but was a common preservation chemical. Large quantities in the industries are reacted with urea to manufacture a type of grease-resistant hard plastic. So grease-resistant plastic. And that would be used to make buttons, appliance and automotive parts, electrical outlets, as well as glue that holds layers of plywood together. The flavor of almonds, okay, is due to a couple aldehydes called benzaldehyde and salicylaldehyde. And so you don't have to memorize the names if you don't want to. You can just say almond flavoring is due to aldehydes. And also the aroma and flavor of cinnamon is largely due to, and this is an easy one to remember if you want to remember this one, cinnamaldehyde. I thought about naming my first daughter that. Cinnamaldehyde. That's, tragically, my wife struck that idea down. Not sure why. Come here, Johnny. Come here, Sally. Come here, cinnamaldehyde. I don't know. I thought it would have been great. But anyways, so here's the structures. What do you see? You see C double bonded to O and then to hydrogen, right? Here we go. Here we go. And here we go. Aldehydes. So in naming aldehydes, it's pretty straightforward. Here's an example of 4 aldehydes. You just copy out the structures and the names. Of course, 1, 2, 3 carbons, prop, right? Propane. If you have an aldehyde functional group at the end, it's propanal. Okay, so if you were to draw these aldehydes, octanal and hexanal, of course this is what they would look like. The aldehyde group is always at the end, and you just count the number of carbons in the chain. And there you have it like that. So here's the answers for that, just to run through that. So that's the lesson today. Ethers, amines, and aldehydes. We did not finish the carbonyl group in this lesson, but ethers, amines, and aldehydes, that's the lesson for that.